Hello, everyone. My name is Kwan, and I'm a cloud specialist from the APAC app dev team based in Hong Kong. I'm the technical lead for Oracle's app dev platform. This includes both, the cloud native application development using Oracle's tools and open source technologies. So in the next hour or so, I hope to give you an overview on how you can quickly build and manage cloud native applications using Oracle's virtual machines, as well as the cloud native services that we offer. Before I jump into the OCI virtual machines and cloud native services, I just want to give you a quick overview of Oracle's cloud infrastructure, as this is the foundation for all our solutions. All right, so it's important. Let me start with the OCI global footprint. Okay, this is a slide Barry shown in his overview session last Friday, and I just want to elaborate a bit more on this as it may help you to decide which region to subscribe to. We currently have data centers in 29 regions across the globe, growing to about 36 regions by June this year. And Singapore will be going live soon around May time. Our regions are made up of commercial sites, dedicated government sites, and interconnect sites to Microsoft Azure data centers. And you can choose the region you want to subscribe to. If you are concerned with latency, then you want to sign up to a region that is close to your home country, such as Seoul, Tokyo, or Singapore. When it comes online, basically for the lower network latency. And if you are looking for a high availability deployment, then you may want to subscribe to a region where it offers multiple availability domains, such as Ashburn, London, or Frankfurt, which I'll talk a bit more about later. Let's go over some core concepts for OCI. You probably be asking why you care, right? And why you want to do, all you want to do is just some coding, right? Well, understanding the OCI design will help you decide how to provision your environment and where to run them, all right? As I said, we operate in regions. A region is basically a metropolitan area. And inside regions, we have multiple data centers. That are called availability domains, and and each region consists of 3 availability domains. These are isolated from each other, and all your resources like compute and database go inside an AD. Okay, so they are like compartments, different data centers, and ADs are wired together over private fiber. Okay, and there's very little latency between them. So this makes it perfect, for high availability and replication of data. We also use a dedicated backbone to connect these ADs together, right? The backbone plugs into the edge where the customers can connect or get direct connection into our network. And inside these ADs, we have built one of the best public cloud networks. It is big, flat, and fast. By flat, I mean it is not oversubscribed, so we can get really low latency, and fast means we support 25 gigabits per second network bandwidth between hosts. We have made some changes into how virtual networking is done as well. What we call this off-box virtualization. As the name implies, we pull all the virtualization out into the network, including storage, networked I/O virtualization. So this generally means that it enables the next layer up, so we can take all the physical resources and plug that into our virtual network. Okay, so this is the basis that lets us do bare metal and engineer a system like Exadata and plug it into this environment, without making any changes. So this is what the fully integrated picture looks like. We also have the largest class of compute and storage option that plugs into this virtualized environment, built using the off-box network virtualization. Okay. Now, I'll go, through some basic cloud network components such as VCN and subnets. They are much more to the network components than I have time for, right? But these will certainly get you started, right? So a VCN or a virtual cloud network is the starting point for any Oracle Cloud infrastructure, all right? A VCN is a software-enabled is really a software-enabled a virtual set, yeah. So VCN is basically a software-defined version, of a traditional network, and VCN is a regional service, and it comes with some, default components, such as a routing table, security list, and DHCP options. You can't delete these default components, all right, as they are required by the VCN to operate correctly. But you can change their configuration, or by creating similar kind of components, such as, a custom routing table. Now, each VCN network is divided into subnets, and each subnet is contained within a single availability domain. All right, and each subnet has a contiguous range of IPs, and they are described, in the insider notation. And subnet IP ranges, may not overlap, and you can have, more than one subnet in an AD for a given VCN. One important point to note is that subnet can also be public or private. All right, so being a public subnet will give you access, over the internet or externally. So a compute instance, for example, that's running, within an AD, will draw their internal IP address and a network configuration from the subnet. Okay. Now, each compute instance running in a VCN has at least one private IP address, right? This means all compute instances in the VCN communicate with each other. A compute instance can also have an optional public IP assigned to it, all right? This is the a public IP address that is in the IPv4 format, and is reachable from the internet, and is assigned to OCI resource, such as, the compute instance or a load balancer, for example. And for a public IP to be reachable over the internet, this VCN must have an internet gateway, all right? And an internet gateway basically, provides a path for network traffic between the VCN and the internet. And after creating an internet gateway, you must add a route for the gateway in the VCN routing table to enable traffic flow. And finally, you need to configure the security list, which is basically a common set of firewall rules, with a subnet, which is applied to all instances launched inside that subnet. Okay, so security list defines the ingress and egress rules that specify the types of traffic, that's allowed in and out of the instances. And you can choose whether, a given rule is stateful or stateless. So that's a pretty quick crash course on VCN. These are the minimal components that you need to know before you can actually start, launching a compute service, right? Now, if we look at what OCI has to offer, in support of application development, you can see that we are very focused on developers. We have developed tools that helps you quickly start building and managing your cloud native applications. I mean, many of these tools are open source tools, and you can bring your own tools to the platform if you wish. We also offer a set of cloud native services based on the best of open source, technologies, including containers, Kubernetes, serverless functions, and more. These are managed services and simplify many, of the administrative overheads that you would normally, experience if you were to install it by yourself. Now, for DevOps, on the right here, we offer tools for software development lifecycle management, such as Visual Builder Studio, which I'll talk, more about in the next session. infrastructure automation, monitoring, logging, alerting, and more. Okay. As for the data management, this includes our autonomous database and MySQL Cloud Service. Again, these are managed services. Now, OCI offers or provides software development kits for all major platforms, so for all major programming languages and frameworks such as Java, Python, Ruby, Go, more. They are all, many of these are open source and available, through GitHub as well. These frameworks. Now, at the bottom of the OCI foundation is made up of compute, storage, networking, and security services. And you have a choice of launching a VM instance or a bare metal, instance from the compute service. So this is probably the quickest way to get started, to start developing, an application on OCI. Just spin up a compute instance and install your tools and software. If it is a Java app, you are developing, you can install a JDK in your compute instance. If it requires a web server, you can install Tomcat or any one of your favorite web servers, right? Now, compute services are the foundation and the most important cloud service of OCI, right? It is offered as bare metal or VM instances, and it is used to implement the worker nodes for our Kubernetes, and serverless functions as well, right? I won't go into all the details, but if you are spinning up, basically, if you're spinning up a compute instance, you can choose from a bare metal or a VM instance, depending on the performance requirement. A bare metal instance, are basically instances when customers get the where the customers get the full server. Okay, this is also referred to as a single tenant model. And the advantage here is that there's no performance overhead, no shared agents, no noisy neighbors. Right. On the other hand, for VMs, virtual machines, their underlying host is virtualized to provide smaller virtual machines and is referred to as multi-tenant model. And the advantage here is flexibility, in regards to the choice of instance shapes. And you have the choice of processors, and storage, again, depending on the performance need. Now, these are some of the standard compute shapes that is available to you. You can pick, the one that's most suitable for your need, whether it is, more processing power your build jobs require, or more memory for running your application. Okay. But if none of that standard shape works for you, you can always choose a flexible shape. With a flexible shape, you can configure the exact number, of OCPU and memory for your VM. But this, flexible shape is only available with the AMD processor right now. Okay. Oracle also provides several pre-built, images for, Oracle Linux, Microsoft Windows, Ubuntu, and CentOS. If you don't like any of these, you can always build your own custom image or bring your own image with your own custom stack of software. And this could, sort of contain the tools that you would use, saving you time and effort. Okay. Now, so the quickest way, as I said, to create a compute instance is from the OCI console, right? And the creation of a compute instance is referred to as launching an instance. And you will need to complete, basically a form by which you see on the screen here, left and right here, by completing this form and choosing the compartment, the availability domain where the instance will be launched. Then you'll need to select an image and choose a shape for an instance. This can either be a VM, bare metal, or flexible shape. Next, you need to select a VCN, and subnet if you already created one. And this is why I covered VCN subnet earlier as you would need to understand them before creating compute instance, because it might be that you need to create those separately. However, if you don't want to use an existing VCN, you can always let it create a new VCN and subnet for you automatically. Okay. And finally, you will need to add the SSH keys if you need to work remotely with it. After you click on the create button, it will take basically a couple of minutes for the compute instance to spin up. Once ready, you can download or push your software to the instance and start working with it. So this is the quickest way to start developing an application on OCI. Basically, just spin up a compute instance and install your tool and software. All right. Just let me show you quickly how you can provision a compute instance on OCI. It might be trivial to you, but to some, but it's actually an interesting experience. Let me just switch to my console. Here's my OCI console login. Basically, I log in as myself. Okay. So there's a couple ways where you can create the instance. You can either, on the home page here, click on create a VM instance, or you can, select from the first menu option here, compute instances. Okay. Let's close this. If I click a create instance, what you will see is what you need to enter is the name of your instance. Select the compartment. Okay, I'm selecting KW here, my own compartment, and then you can select the availability domain ADs where the compute will be instantiated or launched. Okay, so it could be either one of AD 1, 2, or 3. And then by default, the shape is actually a VM. AMD flexible shape. Okay. Now, you can also change the image. The default is the Oracle 7.9, but if you click on change image name button, you will get a list of different pre-built images there. It's a bit slower this morning. Okay, so you can see Ubuntu, CentOS, etc., Oracle Linux, and Windows servers. All right, I cancel that. And then for the as for the flexible shape, I can change shape. I can select, either bare metal, or I can select a different, processor. If I'm selecting Intel, then I get these standard shapes. Let's go back to the flexible shape. Then I can change the number of CPUs here, for example, 2. But I can also change the amount of memory as well. All right, but I don't want to change that. And all I want to do is go and select the network. Here in the network, it's by default offers you a number of virtual network, cloud network that's available in my tenancy, in my account. Okay, I can select any one of these, or you can have created these previously yourself. But I don't want to do that. I want to create a new VCN. Okay, so this will go away and create the VCN and also the subnet for you in the compartment you selected. Okay, and again, if I set that to demo subnet, for example, again in the same compartment, and I leave everything, by default. Here's my public IP address to assign a IP4 address to that. Now at the bottom here, this is very important, right? You need to paste or you need to either generate the key pair, let them generate a key pair for you, or choose a public, key file that you already have, or you can paste it into here. Just so happen I have something already created earlier. Okay, here's my key. I copy that. I come back here. I paste my key here. All right, and I leave everything else as default. I click create, and this should take about less than 2 minutes to launch instance. And during this time, you can actually monitor the progress of this. Yes, for some reason, it's a bit slow this morning. Apology. One interesting things to know is actually we have something called create as a stack. So a stack is basically a Terraform configuration, right? It goes away and creates a Terraform script so that you can go into our resource manager and basically rerun the Terraform script to provision the exact same instance over and over again. So it's repeatable. So that's basically, you know, the infrastructure as code. Okay. Now you can see our instance is being provisioned. One of the things that what you see is that the VCN will be provisioned, and you should be able to see a public IP address here. Okay, the instant access. So I can copy that, or actually I can go into the VCN somewhere. Okay, there. So my VCN is here. I can click into the VCN demo. And you'll see that the VCN and all the subnets have been created before that instance has been launched. Okay, so this is my VCN, right? Called demo, and these are my subnets, demo subnet here. Okay, and once that that instance is ready, if I go back, I should be able to SSH into that. And it should take about a minute and a half, something like that, to provision it. Okay, I think whilst that's happening, I should be able to try. So basically, I'm SSH into my instance. I'm passing my my private key, SSH key, and I'm logging in as OPC as my user, the default cloud user name. And if I try to SSH there, so it's up and running, and there you go. So I'm now inside my compute, okay, my VM. So you can do whatever you want to it now. You can install the software, you can download, whatever SDK or framework that you need to work with. So this is the quickest way to basically get started, okay. Oops. So now, if I go back to my presentation. Okay, so let's take a look at the cloud native services for developing a cloud native application. This is a simplified slide to the one you saw earlier, right? And it's focusing, on the cloud native services. As I said before, we also offer a set of cloud native services based on the best of open source, including Kubernetes, serverless function streaming, events, and API management. But the three key services used to support cloud native development is Oracle's container engine, and the Docker registry called OCI, and a visual, the Visual Builder Studio here. Okay. Now, Visual Builder Studio is a cloud-hosted development platform, with tools for agile team development, code management, and support for continuous integration and continuous delivery, CI/CD automation, right? And the cloud infrastructure registry, OCIR, is a private Docker compliant registry, for storing your Docker images, and Oracle's container engine, which is OKE for short, is a managed Kubernetes service to host your container-based application. So let's go a bit deeper into the container engine for Kubernetes, or OKE for short. So this is a managed Kubernetes service to deploy and run container-based applications. It comes with the tooling to create, scale, and manage standard-based Kubernetes clusters easily, right? So the Kubernetes versions that's running on OKE is basically the standard Kubernetes, releases that you get from CNCF, the Cloud Native Computing Foundation, right? And it is developer friendly. You are able to deploy containerized application quickly, using REST APIs that we provide. But you can also use, standard Kubernetes, commands as well through the kubectl. You can also provision it, with Terraform if you don't want to use or work with the OCI console. Because it is based on Kubernetes, it also supports Docker, all right, and also CRI-O compliant container standard. So components that's running in the gray shaded area here is actually managed by Oracle, right? This includes the OCI R registry and also the storage where your Docker images are stored. And the OCI R registry is based on open standards, and you can easily push and pull Docker images with the familiar, Docker CLI commands and Docker HTTP APIs as well. As for the OKE cluster, the cluster management, component, the Kubernetes master node, and the etcd, repository, and also the container dashboard are Oracle managed. All right. This means Oracle is responsible for upgrading these components. Oracle also ensure the etcd and the master nodes are highly available, okay, by replicating them across the three availability domains that we have. The customer, on the other hand, will manage the worker nodes. All right. So in the shaded blue area here, this is the customer's tenancy and customer's responsibility. You can add or delete nodes, from the clusters, as well as starting and stopping of these worker nodes. The worker nodes are actually implemented with the compute services. They basically compute instances, and they can be either a VM or bare metal nodes, or even a mix of them, by placing them in different node pools. Okay. Now, with just the OKE provision, right? Basically, it's a managed Kubernetes cluster. Developers can start building the application by using their own CI/CD toolchains, such as Jenkins, to push their container images to the OCI registry and deploy them to the OKE cluster. Now, because OKE cluster is provisioned across 3 availability domains, the application will be running basically in a HA mode, right? And it can be continuously, monitored and repaired if needed. So the simplest, if you want to get on Kubernetes, is simply just spin up a OKE cluster, and then you can work with it like if though you are working, with a Kubernetes that's running on premise in your local laptop or data center. Okay. Now, however, what if you want to explore automation further? We could build a CI/CD pipeline, that can be triggered every time, when you commit a code change. This means, we need to store the code in a source code management system such as GitHub, and create a CI/CD pipeline using a CI/CD toolchain such as Jenkins, all right? And that would, basically automate the build, test, and deploy process. But this would, require a lot of integration effort, because, you need to define the build script and integration, between tools in the pipeline. So if you've been using Jenkins, you probably will, understand and appreciate the complexity sometimes, in creating those integrations. However, You could use Oracle Visual Builder Studio, instead as your CI/CD toolchain to build, to test, and push the Docker images into the OCI registry. And in parallel, your images can be deployed to OKE cluster. So this is, a general use case for microservices or container-based application where each microservice can be, written in different languages and running in a container. And the data can be stored in an autonomous, Oracle autonomous transactional processing database because that supports a multi-model, database. So it can support things like a relational data, graph, NoSQL, etc. Basically, this eliminates the overhead of different type of databases. Now, so what is Visual Builder Studio exactly, right? So, VBS for short is our CI/CD toolchain. It's a cloud hosted development, platform or environment. This is very similar to Jenkins or GitLab, the open source CI/CD tools. But the difference is VBS comes out of the box with many of the open source tools integrated. So you don't need to write any script or, for integration from one tool to the next as you would do, with other tools, with other open source tools. Now, VBS also come out of the box, with tools, that get you started, such as a wiki, for collaboration, Bugzilla for issue tracking, a Git repository, which is a private repository for source code management. It also supports different build processes such as Maven, Gradle, and Docker. And during the build, we can also check the quality of your code with SonarQube. Now, for the testing phase, we have support for JUnit and Selenium test tools. For the release and events management, we can connect to your external Slack or PagerDuty. For deployment, you can deploy to an Oracle Cloud service like WebLogic on OCI or to a Kubernetes cluster, either running on premise in your data center or to our managed Kubernetes service OKE, or even to any other cloud, right? The other thing is you can also use Terraform to provision and deploy to our OCI platform as well. And for monitoring, we have the application performance monitoring tools such as APM and log analytics, or you can use the open source tools such as Prometheus and Grafana. So the choice is limitless, right? So we provide a lot of integration with open source tools. Okay. Now, so let's go into a demo. So probably give you a bit more idea what I'm talking about. So in this demo, I'll show you how to provision OKE, but also how you can quickly build, a cloud native application using our, Visual Builder Studio, VBS. Okay. Right. So I'm back in my OCI console, and you go click on the menu button here. Right down the bottom or near the bottom here, I have something called the developer services. Okay. And you have a choice of different cloud native services. So I've got Kubernetes clusters, container registry, function, and API management. So let's click into the Kubernetes cluster. Here in my own compartment, again, KW, I should have one cluster shown or defined here, which I will actually use later. But okay, so this is the cluster that I have running. But to create a cluster, you can simply use the one button, create. So basically click on create cluster, and you have a choice of quick create or custom create. So with the quick create, it basically creates all the important, the most basic resources for you, all the default components. So things like the VCN, the internet gateway, the NAT, the Kubernetes clusters, and all the worker nodes, right? Whereas in the custom create, you have to provide all the resources, upfront. So things like your subnets, your VCN, etc. So let's go with the quick create, okay? And I'll do a launch workflow. Here, again, I will change my cluster name to demo. I will create it in my cluster, sorry, in my compartment. Here, I have a choice of different Kubernetes version, and I'll leave it on the latest, the 18.10. And then you have option of creating your worker node as either a private worker node or public worker node. So the difference is basically with the private worker nodes is these are only accessible within the cluster and they can communicate with each other using the private IP addresses, whereas the public worker nodes, you can provide a SSH key to it so that you can SSH directly into those worker nodes, okay? I'll just leave it on private for now. And then, you have a choice of compute shape, right? And a lot of these are either bare metal, VM for bare metal, or you can choose one of the VM shapes, standard shapes, okay? But I can also choose a flexible shape, a VM flexible shape. Again, this is very similar to what we've seen before with the flex shape configuration. Again, you can choose different, CPU and memory. Down here, you can choose different number of worker nodes. All right, by default, we'll create 3 worker nodes, so 1 in each AD. All right, so that's our cluster is spread across the 3 ADs to improve availability. Okay, I'll leave it on 3, and then I'll need to review, my configurations before I can click on create cluster. So when I click on this, it basically will go away and create all the resources, the master node and all the worker node pools with the 3 worker nodes in them. And this will take about 10 minutes, 10 to 15 minutes maximum, okay? If you were to install, Kubernetes in your, data center or on your laptop, it will take a lot longer. Okay, so I've got a limit exceeded. What I mean is because I actually probably have more clusters created in different regions, and I'm not able to create more right now unless I switch to something else. Okay, but it gives you an idea, how easy it is done. Okay. Now, the next thing I want to show you is once a cluster is created. So if I were to go back to my Kubernetes cluster. I have a cluster here previously, and this is the Kubernetes dashboards connected, all right, to that cluster. Okay, and if I click on the nodes, let's reload this. I click on nodes. You'll see that I have 3 worker nodes, and these actually are compute VMs, running in the background, and they are using, their own IP addresses, private IP addresses to communicate with each other. And you can see the compute is a VM of the standard, 2.1 shape. Okay. Now, also in the cluster, you can see I have a number of deployments here. So I have an application called Cafe Supremo, I have a service broker, etc., catalog. So this cluster is running, and you can access it using the dashboard or using the standard Kubernetes kube control, right? kubectl to connect to it. Okay. Now, once I have the environment, up and running, this OKE, I can go to my Visual Builder Studio, to create my application and deploy to this, all right? So here, this is the homepage for my VBS. What you see is on the left-hand side are all the available tools that are available to me. And in the middle here, these are a list of projects that I have, all right? And then along the top, I have more options, information about my account, but also my virtual machines, okay? So what are these virtual machines? So these virtual machines are basically my build servers, right? So for every project, you probably want to have a build server for your application, for your project, because the application might use different build tools. All right. So for example, in my virtual machine, I have a Cafe Supremo server here, build server here. It's currently running, and this is actually using a compute shape again, using a VM shape standard 2.1. It's running in my Phoenix region. And if I click into my template, okay, my build server is using a template that consists of these software packages, right? And you can add, or remove packages from your build servers. So I have Docker here, I have Java here, I have my CTL, here. I've also have Node.js. So these are all available, on my server. So if I need to build something, using these tools, they will be available to me. But I can also, add other software to it. Okay, so all the one in greens are what's been added. I can also add Helm to it, Groovy, etc. Right? So you can customize your build server. Now, if I go back to my project, and let's say I want to create a project, okay? I want to create a brand new project for my application. So I click on create, and let's say create a project called demo. Very easily click next. Right? You can either create an empty project, or you can want to create one with a Git repository, simply with a simple readme.md file in it. Okay, and then you can import your other Git repository from externally, either from GitHub, or GitLab, whatever. Okay, I can click next. So I tell it to initialize it with my readme file, and it'll go away and start creating, provisioning my, my project. And you can see that these are all the tools that will be included, all right? So out of the box, we support agile development. We have build tools. So this uses Hudson, as my CI/CD engine. So it allows you to build, but also to create the pipelines. I have also have a issue tracking tool. So this is based on Bugzilla. I have Docker, so I can create links to my external Docker registry, which can be OCI running on my OCI. I have a wiki for creating project pages. I have merge requests, etc. So these tools, well, once a project is finished provisioning, these tools will be available to you. Okay. But in the meantime, while that's creating, that'll probably take a couple of minutes. I want to go and show you an existing project I have. Okay, so going to my Cafe Supremo project here. This is my project home. Okay, and you can see that in the middle here, these are all the activities that's happened, in the past. So this morning, I've tried building the application. I basically I made some change. I pushed the change into my Git repository, and then I just did a build and deploy. Okay, so this is a build, and this one's deploy. Okay, and on the right here, I have a list of my repositories. So under the Git, I have a Git repository. So this is where all my source code is stored. But you can also create a Maven, repository that contains your Maven dependency, also any npm, dependency, as well as your Docker registry. So you can pull images and push images to your Docker registry by defining the passing credentials and the location of your registry here. But also you can also create a project team. So these are members of my team here. So these will have access to this project. And then on the left here, like I said, these are all the tools that's available to me. And in the build tool here, you see that I have a number of build jobs. Okay, but these jobs can be executed independently, or I can create a pipeline, a CI/CD pipeline. So if I click on the pipeline along the top here, you see that I have created a pipeline here. Basically, whenever I commit my, do a push or commit to the code to my repository, it will automatically trigger a build job. and it will execute the Cafe Supremo build. And if the build is successful, then it will automatically trigger the next one, which is deployed to my OKE cluster. Okay. Now, let's go to my Git repository. I just want to show you how easily this can be done. I'll trigger a build first, and I'll then walk you through the configuration part for my build job. Okay. So in my source code, let's say I want to make a change to my configuration of my my application. At the moment, I've got login enabled, which is set to false, so it's disabled. What if I want to enable this? Let's set this to true. Okay, and I do commit, and I say enable login. Okay. Now, the moment I commit the code change here, it should automatically trigger a build job. So if I go back into my Cafe Supremo build, yeah, there's something it's a bit sluggish this morning. What should happen is you should be able to see the build triggered immediately. Oh, there you go. So the executor assigned. So basically, this will be using the build server that I defined, that I showed you earlier, and I can follow the progress of this by clicking into my build log, which is basically the console output from my build server. Okay, and you can see that it's actually connected to my Git repository. Okay, trying to pull the source down, but also I'm connecting to my my Docker registry. Okay. Now, what is it doing actually? All right. How we arrived there. So I go into build job here. Okay, and I do a config. So this is the configuration for this particular build job. Right. So I'm telling it this is the Git repository to pull the source from, because I only have one Git repository, so I'm connecting to Git, so to Cafe Supremo OSB Git only. But also I specified that it will automatically perform the build when I do a source code management commit. So this little checkbox here will automatically trigger this job when the commit happens on this repository. Okay, and it will automatically do a build from the branch master. But you can select other branches if you have, different branches like defect or different releases, etc. Now, the next part is the steps. These are my build steps inside this job. So the first step here is I'm doing a Docker login, all right? And basically it's connecting to my OCIR, my registry, okay? And I'm passing it the credential here, username, password. So that's what you saw in the log just now. So I'm doing the login. The next thing is I'm running a Docker build. Okay, this is the Docker application. I have a Docker file in my Git repository. So it'll be building the from the Docker file, and then creating the Docker image and then pushing that to my OCIR registry. I call it Cafe Supremo latest. Okay. Now, the last part of my my build job is after the image is completed, then I'll push this. All right, again, push it to my Docker registry in my OCIR. So this is how easy it is. Now, then once this completed, it should automatically leave page. Okay, so you can see that the previous build has completed. Okay, it took 2 minutes and 33 seconds. It will automatically trigger the next part of my build job, which is deployed to OKE. Okay, so this should, okay, it's waiting for it to execute. Once this, completes, this again takes about 46 seconds. It will automatically deploy, to my cluster. Now, while that's building, I can show you some of the things like issues. So this is the issue tracking. So you can have bug defects, enhancements, or just simply tags. I can also define my Docker registry to any one of these, repository in my registry. And if you are, working with agile development, right? So we have something called boards. So this is basically supports the Scrum, agile development, and you can create, backlogs. So these are all the tasks or the defects that is outstanding, and I can, create sprints. So sprints are basically short duration for a particular, task, right? So for example, here I have, I can have a defect list, I can have task or enhancement. So under defect, I might have a defect 11 that's assigned to me. So to do, that's to do. And I can move it from to do to in progress. Okay, click OK. Now it's in progress. But then from in progress, I can also, move to completed. Okay. Once it's done, so you can track the progress of your sprint and your task with the system, but also you can look at the reports. So these are basically the sprint reports. Basically, if you can check, let's say for example, the number of issues outstanding, or how many days are left for a particular task. Okay, so this is quite useful if you are practicing agile development. And Visual Builder is actually free. This is free to you. You don't need to pay anything for this, apart from the storage of your registry if you exceed 20 gigabyte. Okay, and it comes free if you are subscribed to Oracle cloud infrastructure. So basically, if you're using a compute, then you have access to this. Okay. So if I go back to my build, so you can see that now my deploy is completed. And if I go to my Kubernetes dashboard, you can see that somewhere down here, my replica set, okay, it was just deployed about 2 minutes ago. Okay, so this is how easy it is to do, CI/CD or cloud native development with Oracle. Okay, good. Right, so going back to the last part of my presentation, just to wrap up. So, due to the limited time, I have today, I haven't been able to cover everything, on the slide. But hopefully, I've given you a taste on how Oracle can support your cloud native application development need. All right, and just to wrap up. OCI or Oracle Cloud Infrastructure supports development in any language and framework. It comes with tools and services that are complete, integrated, and open. You can spin up a compute VM to get started quickly, or you can leverage one of the managed native services. Oracle is not just supporting open source. We are actually embracing it. All right, we are a sponsor and contributor to the Cloud Native Computing Foundation, CNCF. And if you don't know, CNCF is actually responsible for the Kubernetes standard, and we have many of our products to run, on Kubernetes. And just before we finish, here is a list of hands-on labs, from Oracle Live Labs that you can try. The labs show how you can build a Java application from on a compute VM to migrating or building and deploying a container application to OKE with Visual Builder Studio. So these would be good for you to explore further and try out different scenarios. Okay. So that's all I have for today. Thank you for joining us, and I hope that it's been useful. Okay, thank you.